Continuing on in chapter 11 today. Today we are going to talk about surface area, lateral area, and volume of pyramids. All right, what is a pyramid? A pyramid is a 3D figure that has one polygonal base and all the lateral faces are triangles. Okay, so they meet at one unique point. It is called the vertex. So we have a vertex where all those points are meeting, and we have a polygonal base. Now, once again, the name is off of the base. Whatever the base is, that's how we name a pyramid. So for example, here in the first one, it is called a square pyramid because my base is a square. Second one here, this one is called a triangular pyramid because my base is a triangle. Thirdly, I have a pentagonal pyramid. And fourthly, hexagonal pyramid. Okay. Now, I also want to introduce you to two other things that are going to show up in a pyramid that we will need for two different formulas. The first one is when we have a line coming down from the vertex to the side on the triangle lateral face. This takes on a new name. It is called the slant height. Okay? Then we also have a line, I'm going to draw it here in red so you see it, that comes down into the middle of the base and is perpendicular, and that is called the height. Okay? So what you have to think about is the slant height is on the slant of the triangle lateral sides, where the height goes from the vertex to the base, perpendicular to the base, right down through the middle of the pyramid. So if you kind of think of attaching a string from the top of the pyramid, running it straight down through the pyramid all the way to the base, that's the height. If I lay a string on the side of the pyramid from the vertex to the base, that is the slant height because it's going to run down the side of the triangle. Okay, so we're going to need both of those measurements. The height going through the middle of the figure and the slant height on the side of the figure. All right, so here's the two formulas we are going to use today. So first one, lateral area of a pyramid. We're going to take the perimeter of the base times the slant height. And then we're going to take that and divide it by 2. Okay? So we have perimeter of the base times the slant height divided by 2. And that is the lateral area. Then you'll notice that part of the formula is over here. And all we simply do is add on the area of the base. All right, so let's take a look at this then. So we're going to start here on the first one. If you notice, I have a square pyramid. Okay, so I'm going to start off with the lateral area. So the first thing I want to know is I'm going to find all three pieces. I'm going to find the base, I'm going to find the perimeter, and then I'm going to find the slant height. So the base here would be the square, so I simply take 13 times 13, and that is 169. Then the perimeter of the base would be 13 plus 13 plus 13 plus 13, which is 52. The slant height here would be 21. Okay, so now let's break it into our two formulas. So the lateral area is equal to the perimeter, 52, times the slant height, 21, and we're going to take that and divide it by 2. So we're literally just going to go 52 times 21, press equals, and that's going to get us 1092. Then divide that by 2, and that's going to give us a lateral area of 546 square kilometers. Then I'm going to come back, and now I'm going to take the surface area, and I'm just going to add in the area of the base. So now I take the 169, added to the lateral height, which is the 546, and I'm going to add that together, and that's going to get me a total surface area of 715 square kilometers. Okay, so that's how we do that process. We just start there and we work through that. Okay, now what I'm going to do is I'm going to erase that, then make sure you get that down so that we have room to work the second one out here. So now let's start on the second one. So on the second one, if you notice, I have a triangular base. So this is a triangular pyramid. So again, I'm going to find 3 things. I'm going to find the base, the perimeter, and the slant height. Well, we know the slant height's real easy. It's marked 20.6. That's my slant height. So now the perimeter here is it's an equilateral triangle. So I'm going to go 17, and I could go 17 plus 17 plus 17, or I could just take 17 times 3, and that's going to get me 51. Then my last one is I need to find the area of the triangle base. So remember, we're looking for that right angle, which is there. So that is 14.7 multiplied to the side of 17. So if we take 14.7 times 17, take that, divide it by 2, and that's going to give me 124.95. So now let's go through. Let's find the lateral area. For the lateral area, remember, we just take the perimeter times the slant height, and we're going to divide that by 2. So 51 times 20.6, and that's going to give me, and then I'm going to take that, divide it by 2. So my lateral area is going to be 525.3 square inches. Then to find my surface area, I'm just going to take that and add on the base. So remember, the base is 124.95, and we're going to add to it 525.3. And that's going to get me 650.25 square inches. Okay, so that's how we find the lateral area and the surface area of a pyramid. Okay, let's go ahead. Let's try another one now. Now, when we look at this next one, we have a pentagonal pyramid. Okay, so we're going to have to do a little bit of work here. It's irregular, so we're going to have to do a little bit of work. So first thing I'm going to do is try to figure out what I have and what I need. So I'm going to start off with my base. I need my perimeter, and I need my slant height. Well, I know the slant height is 17.8. It's right here. That's my slant height because it's on the outside of the lateral face. I also know the apothem is 11. I know I have 5 sides to the base, but I do not know what the measurement of a side is. Okay, so now my next step is I need to connect that to the side. I know the apothem is 11. I'm looking for X. So if I cut out that triangle, here's what we now have. I know this is 11. On a pentagon, remember 360 divided by 5 is 72 degrees. So half of that's going to make that 36 degrees. And that's going to be X. So now we know the tangent of 36 is equal to x over 11. So x must equal 11 times the tangent of 36. So we take our calculator, 11 times tangent 36. That's going to equal approximately 7.99. So I'm going to take that and just call it 8. It's going to round up and round up. So I'm going to call it 8.0. Now remember, that's only half. So the full length is going to be 16. So I'm going to plug 16 up here. So now I'm going to take 16 times 5 times 11 divided by 2, and that's going to give us an area of 440 for the base. Then the perimeter, we know that is 5 sides times 16, which is 80. So now we are ready to find the lateral area. So the lateral area, remember, that is your perimeter times the slant height. And then we're going to take that and divide it by 2. So 80 times 17.8 gives me 1424. We're going to take that divided by 2, and that would be 712 square inches. Then I'm going to come back, and now I'm going to do the surface area. So the surface area is the area of the base added to the lateral area, which is 712. So 440 plus 712, and that's going to give us 1,152 square inches. And that is how we work through that process of lateral area and surface area of pyramids. So now let's move to a volume. Now, on volume, there's a difference here. So this is where we come back to the height of the pyramid. So this is no longer the slant height. This is the height, the one dropping from the vertex to the base, perpendicular to the base, down the middle of the pyramid. And the formula goes, the area of the base times the height of the pyramid divided by 3. So when we start in over here, I notice that I have a triangle for the base. Here is the right angle of that triangle. So if we want to start off, we can go, okay, the base then would be 1/2. The 12 and the 9 is what makes that up. So I would go 1/2 times 12 times 9. So that is going to be 54. Then I know the height going straight down through the middle right here. This is the height. So that is going to be 8. So my volume here is going to equal the area of the base, 54, times the height divided by 3. So I'm going to come in, 54 times 8 is 432. I'm going to divide that by 3, and we end up with 144 cubic feet. Okay, and that's how we do that process. Now, I'm going to give you a second to finish writing that down before I move to the second one, because we're going to have to do a little bit more work, so I'm going to need to erase that to have enough room to continue. All right, so here we go. We're going to erase this up. Now let's take a look at the second figure. Now, on this second figure, the first thing I need you to understand is when you look at this figure, that 21 does not represent the height. That is the slant height. But in order to find the volume, we have to know the height. And the height is going to come down here. It's going to be perpendicular to the base, but it would make a right triangle with half of the base side length and the slant height. So what I'm going to do is I'm going to pick that triangle off just so you can see it here. So I have something that looks like this. This is the height of the triangle. This is the slant height of the triangle. And the base would be 6.5, which is half of the side length. So to find the height, I got to solve that. So what I'm going to do is I'm going to start off and I'm going to say, okay, height squared plus 6.5 squared is equal to 21 squared. So we're just going to do Pythagorean theorem. So I'm just going to type all this in. We know we're going to subtract it. So I'm going to go 21 squared minus 6.5 squared. And that's going to give me a value of 398.75. I'm then going to take the square root of 398.75. And that's going to give me 19.9. So what I'm going to do is I'm just going to call that 20. 19.96, it would round up. So I'm going to call that 20.0. So the height here is going to be 20. So now let's go through and fill in the other. So the first thing I need to know is I need to know the base. What is the area of the base? Well, again, it's a square, so I'm just simply going to go 13 times 13, which is 169. Then I need the height, and we just found that to be 20.0. So now as I come in here to work, the volume is equal to 169 times 20 divided by 3. So the volume is equal to 169 times 20 equals 3,380. And I'm going to divide that by 3. And that's going to give me 1,126.7 cubic kilometers. Okay? And that's how we would work that process out when we have to find the height and we're not given it, when we're just given the slant height in that process. All right, let's try one more here. Volume of a pyramid. So again, remember our volume formula, area of the base times the height divided by 3. So I need to know those things. So I'm going to start off, I'm going to go my base, area of my base, and my height. Well, in this drawing, I know my height is 13. So right away, I know that. To find my area of the base, I have a regular hexagon. So what I'm going to do is I'm going to start off, I know I'm going to divide that by 2. Then I need my apothem. I need the number of sides and the side length. Well, I know the side length is 11. We already said it's a hexagon, so there's 6 sides. So the last thing I need is, what is the apothem length? So this is what I'm looking for. Half of 11 is 5.5. Remember, in a hexagon, I have 360 divided by 6, which is 60 degrees. So if I draw that triangle down here, I've got this to be 30 degrees, which is half of that. I know this to be 5.5, and here is my apothem. So that's going to give me the tangent of 30 degrees is equal to 5.5 divided by A. This is the point where we take and multiply by A and then divide by the tangent. So my apothem is equal to 5.5 divided by the tangent of 30. And that's going to equal 9.52. So I'm going to leave it 9.5. Okay, so now we're ready to find the volume then. The volume is equal to the area of the base. So we need to just work that out real quick. So 9.5 times 6 times 11 is 627. Take that, divide that by 2. And we get 313.5. So now my volume is going to be 313.5 times the height, which is 13. And we're going to take that and divide it by 3. So now my volume, 313 times 13, that's going to get me 407.5, and I'm going to take and divide that by 3 now. And that's going to leave me with 1,358.5 cubic kilometers. And that is the volume of that hexagonal pyramid. So that is our new formulas for today.